We are going to be reviewing a few topics from geometry which are helpful to us in the study of trigonometry. One of these is the concept of supplementary angles. Supplementary angles are two angles which together seem to form a straight line. If it looks like a straight line in geometry or trigonometry, you can assume that it is. It's one of the assumptions you can make. And therefore, the angle measurements should add to the measure of a straight angle or straight line, which is 180 degrees. If angle ADC is 60 and angle ADB is next to it and they form a straight line, this angle measurement must be 120. Obviously, we can click and change the measure of one of these angles. And if I change measure angle ADC to 110 degrees, the measure of angle ADB is now 70 degrees. Now the main reason that we're looking at supplementary angles in trigonometry is because inside of a triangle we're often asked to find all the missing measurements, whether they be angles or side lengths. And so sometimes in trigonometry you're given a problem where one angle on the outside is given. We call this an exterior angle measurement. It's more helpful for you to find the measurement of an angle inside the triangle. So you need to be able to remember that with supplementary angles you can calculate this missing angle measurement. We knew that was 170 before, so I'm just going to change this to, let's say, 71.3 degrees. We could subtract this from 180 to get our internal angle measurement. And again, it's pretty easily done. So this is how you're most likely to find the concept of supplementary angles showing up in a trigonometric problem. Another review topic from geometry relates to complementary angles. Complementary angles are shown in this diagram as the light orange angle and the light blue angle, angle IHJ and angle JHF. Their measurements, when you add them together, give you 90 degrees. They're called complementary angles. In the meantime, I would like to say that angle GHI is shown in this diagram to really prove that these two angles together have to add to 90 degrees, since all three add to 180. 90-degree angles are called right angles. Another way you know this would be a 90-degree angle is if it had a small square drawn here. That's a symbol that indicates 90 degrees. We're careful in geometry to never assume a 90-degree angle unless we're told otherwise. However, you will see that in trigonometry, in many real-world problems, you are trying to find the height of something, a person, a building, a tree, a cliff. And your assumption most of the time, unless told otherwise, is that that's a 90-degree angle formed by an object standing on the ground. Once again, it's a situation where for complementary angles, if you're given the measurement of one, you can subtract this angle measurement from 90 degrees to get the remaining angle measurement. What remains constant is the sum of these measurements is always equal to 90 degrees. The problem with this diagram is it's showing complementary angles next to each other, and in trigonometry often complementary angles are not adjacent to each other. So I'd like to show you that more common diagram. This diagram relates to a geometry review topic known as the triangle angle sum. The three angles in any triangle always add to 180 degrees. Now, the reason I have this diagram the way it is to start with is that I've got a 90-degree angle at angle A. Angle BAC is another name for angle A in this corner. It's close to 90 degrees. It's as close as I can get with the software package, so we'll work with that. We'll assume it's 90 degrees. And as it is, the other two angles in the triangle, since all three have to add to 180, these two must add to 90, and they do. These two angles in this right triangle are complementary angles. Now generally I can change the shape of the entire triangle just by clicking and moving one point, and I'm going to do that by clicking on point B. And I'm now changing angle A so that it's larger than 90 degrees. It's now 126.7. Obviously the other two angles have changed as well. Again, the sum has to be 180. This is an obtuse angle. Its measure is greater than 90. Since this triangle has an obtuse angle in it, we call it an obtuse triangle. I'm going to click point B again and just demonstrate to you quickly that it's possible as well to have an angle that's less than 90 degrees. If all three are less than 90, we call them acute angles, and we name the triangle an acute triangle. So we have three possible triangles that you can see based on angle measurement. A right triangle, one angle is equal to 90, an obtuse triangle where an angle is greater than 90 degrees, and an acute triangle where all three angles are less than 90 degrees. Lastly, let's just reinforce the fact that if you know that all three angles add to 180 degrees, if somebody gives you two angle measurements, you can easily calculate the third. 180 degrees minus 47.1 minus 105.8 should give you the right answer for angle B. Let's just quickly do that on a calculator. I cannot display my answer on the screen without showing lots of extraneous objects. I'm getting 27.1 degrees for the measure of angle B.